Hi everyone, Dr. Tracy here. I'm going to talk about basic data types. Now, basic data types sounds like we already did this chapter, right? Back in data storage formats or something like that. But basic data types is now where we're pulling in that information about data storage types and arithmetic in the computer, and we're comparing it to what happens in a computer program. So when you program in C or C++ or many languages, you have some possible values that take on the type of data that they're going to represent. And so this chapter is mainly about the way that we use these explicitly stated data types using C. So that's what the examples will be in. The basic data type, and you see up here it's showing a comparison of 32 and 64-bit architecture. The Raspberry Pi is in 32-bit mode, so some of it doesn't apply. And since this text was built for using the 32-bit Raspberry Pi, that's why this is listed in here. But for right now, we've got all of the things. So byte, half word, word, double word, quad word. These are the way that the data is stored within the computer itself. So a byte is 8 bits. So obviously a byte would be 8. But a half word is 16 bits. A word is 32 bits. A double word is 64 and a quad word is 128. And it doesn't have to be words. That's just what they're called. And that just shows how we can store bits of data. Now we have several data types that are used according to their data typing, whether it's an integer or a float or Boolean or double. And you can see what the size of what is available there. Double is very commonly used, and it uses double word. So that's 128 bits that can make up the combination of whatever is contained within that data value. So any given real world value that can be represented in more than one data type. So we can think of 123 in an integer format, but we can also pull it out by characters. And so defining the way that an integer is represented would require a certain number of memory to see what the possibility is. So this example, even though it's 123, converted to hexadecimal, would require 4 bytes of memory, because so it would take up 31, 32, 33, 0 to demonstrate that. Okay, C programmers use the functions that are part of the standard input-output library. And so in your C programming, you're going to use the CIN and COUT function to do the conversions between integer and character formats, since they can be both. And so the library functions in the code segments are going to take whatever is inputted and then run it through the library to see how it will be returned into what data type. So these first exercises we're going to get through doing hexadecimal to integer conversion. The logic is written on how the program will work. While there's more characters, use the shift left bits to use the shift value in order to convert something to an integer and see the number of in order to multiply it. And this whole shifting, the C shift operators, so you can see the example here in C. It says enter an integer, and then it uses the scanf to find this integer, and then to raise it, it just shifts. The whole idea of shifting as an arithmetic tool within a computer program is because if you think about it, if you're working in decimals, the first character is the ones place. The second character is the tens place. So, and the third character is the hundreds place. So literally, if we want to create something to the 10th power or by one decimal, we just shift it out to the left. And so that's what this program is going to do. It's using the power to multiply, raised by a power by using a bitwise shift. The programming exercise in this chapter is you're going to enter it, and then you got to explain the results, because the results are going to come back a little bit different. The bitwise logical operations here, and inclusive or, exclusive or, and complement. So as you're working, this is the comparison to what would be a truth table. If this is true and that is true, if you've used anything with Boolean descriptors, then the truth tables that are built by using and, or, not is what's demonstrated in the bitwise logical operations. So the truth tables establish how we use these inputs if we're talking about zeros and ones. And it works the same as the truth tables of if it's true and if it's false, then they're both true or both false. And the logical operators correspond. If we have an and, then they have to be both the same. The only way that an and will be true is if they are both true. An inclusive or says the only way that they will be true is if one or both are true. An exclusive or says the only one will be true if one and only one is true. And complement says if it's false, then it's true. If it's true, then it's false. So that's like the not example. So this is and or in complement. Now we prepared to see how we convert from ASCII character code into an integer format. And we use the and operator for comparison to look at the conversion between hexadecimal character and its corresponding integer value. And that's what the conversion is done inside of the computer to change it from a character to an integer. So there's more programming exercises that relate to that reads the characters until the user hits enter and then converts them to integer format. All right, I hope that helps. That gets you through just this quick little, we have this last thing that says other codes. I do have an extra credit assignment that I posted. There are no assignments associated with other codes, but there is an extra credit assignment. So you could check back on the main page under extra credit because I said what are the uses of each of the binary codes, BCD and gray code, and explain why and how they're used. So if you want extra credit, there you go. All right, guys, talk to you soon.